All right, I think we'll go ahead and get started now. I've started the recording, thankfully. This week we'll be going through equipment. So everyone should have received the email that I sent around with the pages associated with electrical and mechanical equipment. We'll be going through the nuances of how exactly you go about evaluating equipment specifically. I also attached the duct takeoff update. There was an error spotted in two of the formulas. So that's been circulated as well. And that's exactly what this pilot is for, us figuring out some of the gaps that need to be addressed and testing this en masse. So thank you very much for giving that feedback. And hopefully we continue to receive that throughout the pilot. So just, I guess our schedule at a glance here, we've got mechanical and electrical equipment this week, and then next week will be the Q&A, and then the following week we'll have our fixtures section, which covers a bunch of different areas, light fixtures, PV panels, plumbing fixtures, and vertical transportation. But otherwise, we're on schedule. So just to review at a high level what we found as part of the case study that's in the guide, the contributions of electrical and mechanical equipment are significant as the hydronic systems was what we found on this particular building, but remains to be seen what that will be in total for other buildings. In our review with CLF, I think there's always a question around, does your DOAS really weigh that much? And that came up actually with Aurora from CLF, who's doing the review for us. And yes, it weighed 36,000 pounds on this project. And that's not unsurprising to those of us who have spec'd those units before. So I think continuing to kind of get those insights around specific pieces of equipment and their contributions to the overall puzzle, because it's a sum of small parts. So again, on this project in particular, we were able to graph out all of the different pieces of equipment, mechanical equipment in particular, and their individual contributions. So the air handling units in particular had, 9 kg CO2 per meter squared, which is a significant chunk of that overall proportion. But you can kind of see down from there the vastly spec'd terminal units being chilled beams. That was another high contributor. Heat exchangers tend to be really heavy metallic objects, so that was another high contributor there. But just to see the kind of range of what we can expect there, and then also to see the contributions of equipment across mechanical, plumbing, fire protection, and electrical. You've got pieces of equipment in each of those different scopes, but we see that its contribution to mechanical scope is, far and away the largest chunk, I guess, next to piping, where under plumbing, you may not have quite as many pieces of equipment, similar to fire protection with the fire pumps and jockey pumps that you might see there, but not much else. And then similarly on electrical, we saw a large proportion of that scope for things like generators, panel boards, being significant contributors. Rachel, hand it back over to you to cover the agenda.
So for today, we'll go through a quick introduction, and then Joel will take on the EPDs and scaling, and then Rachel will jump in with equipment takeoffs and wrap it up looking at the results. Getting into the scope of what we're going to talk about today, we're really looking at the MEP equipment. So that's all your mechanical, plumbing, fire protection, electrical equipment. It does not include telecommunications equipment. We typically don't have a lot of information on that going into the design. It's the primary and large pieces of secondary equipment. So like Kaylee said, it's the air handling units, the VAV boxes, it's transformers and distribution gear and branch circuit panels. It's not getting all the way down to the control valves and the nitty-gritty stuff. Vertical transportation, PV, lighting, all that stuff is going to be covered later on. So hold on, wait for that. And then it doesn't include, the really small stuff. Like I said, the control devices, fixtures, plugs, receptacles, air terminals. That's not part of what we're going to be talking today. Those are exempted from the study. The big portion of this, do you want to take questions as we go or wait until the end?
We can take one if you have it, Annika.
Yeah, I was just going to ask the reasoning behind leaving air terminals out. We found that because they're all usually one type of metal, like even without an EPD, it's pretty easy to include for them.
I think the rationale on that was the weight of them. We didn't have a good metric for that. Is that your recollection too, Kaylee?
It was a bit of that, and also assuming that the air terminal proportion would be equivalent to the ductwork, right? So you can, similar to fittings, right? Or valves, dampers, right? You can assume that there are proportional amounts of all of those elements. And I think with this study in particular, we're trying to get the 80% with the 20%, not so much focusing on was it a linear, was it a 2x2, 1x1 kind of grill. I think that that nuance wasn't something that we wanted to do as part of this study. If you have found that it's a significant contributor over the proportions of what we've studied so far, we can make a case for it being included, but so far that hasn't been the case. Also, just the amount of EPDs in that space is lacking, but to your point, they're metallic objects similar to ductwork. You could probably scale, but I think finding their equivalent weight, the juice didn't feel worth the squeeze when we went through the initial exercise.
That's fair. I guess just thinking like this, if the goal of this guide is to really teach a lot of people moving forward, and a lot of people are going to be relying on it, then like the things we've chosen or you've chosen to exclude from this guide are going to have like a big long-term, I guess, carryover effect that people will continually not add them.
Yes.
Um,
Yes, that's understandable. And what we tried to do was take 240P's inclusions and Rick's inclusions and meet somewhere in the middle, right? Rick's asked for 95% of everything. We didn't go that far, but 240P is asking for way too little in the MEP space. So we tried to strike a nice balance of trying to find what the big movers were in these systems, while not inundating users with having to gather too much data. So if we can find a fast way of tallying up the air terminals, if you want to take a pass at that, Annika, and send it over to the working group, we could always think about its inclusion over the next month.
Fair. Yeah, I'll give that some thought. Thanks.
One thing that we're going to talk about a lot, especially in the scaling conversation, is the MEP equipment declared units. Weight is the preferred methodology for scaling this, and I'm sure Rachel's going to get into this a lot more. But we ran across a number of different instances where we didn't have weight on all the equipment, and we'll go through later on our methodology for how we scaled all these things based on different methodologies, whether it was capacity or length or area or unit quantities, and get into some of the details on that. But really, the message here is, where we can get weight, these are all heavy metallic objects generally. That's kind of the preferred methodology for the declared units. Turn over to Joel.
Yeah, so let's talk about some mechanical equipment EPDs. So ideally, we're looking for, and this, could apply relatively across the board until we get down to some of the bottom bullets for any of the EPDs we're looking for, but unexpired. So typical lifetime for an EPD is 5 years. It's third-party verified. So ideally, we want one that is not created by an internal tool or internal team. And then, if possible, matches the country or region where the project is expecting to procure the equipment from, just to make sure we're getting the appropriate grid electricity during manufacturing. And then this is where we really struggle in the mechanical equipment piece, is where the technology and then the actual equipment most closely resembles the scheduled equipment. So you'll see in a couple slides, we had to make some rather loose interpretations of what EPDs are available. But again, this is a best case effort. It's also a push to a lot of the manufacturers to put out EPDs for their equipment to give us better data. But right now, we just have to use what's available and match up as best we can. Yeah, so like Brian touched on, ideally when we're scaling the equipment, we'd like to use weight for a lot of the equipment. It is heavily metallic, so it's what we feel is the best way to accurately, or at least closely, capture the appropriate embodied carbon of this equipment. You saw the drop down in a previous slide of where you can select the unit. And then we're using that A1 to A3 GWP data. You can also see in this image here, we're comparing if you choose feet or linear feet for this chill beam example versus the actual weight of the chill beam EPD versus the scheduled weight from the model. Now they're pretty close, but there is still a 7,000 kilogram difference between the two. Yeah, so the EPDs, here's an example from our case study where we had to make a rather liberal interpretation of the EPD. So for the pumps, so for example, the equipment on the right, it was one of the modeled pumps for Weimer Hall. And then the Grundfos circulator pump on the left was an EPD that was available for pumps. They're obviously not similar in scale. We have a 2.25 kilogram pump that for the EPD and one nearly 400 kilograms for the centrifugal pump. But again, we're kind of using our best information that we have available here. So again, that's why weight makes a lot of sense for a majority of mechanical equipment. And then I guess just a caveat here, I think we've touched on it in previous sessions here, but we will have to a lot of times reach out to manufacturers because to get weights on equipment. So I just put in a little correspondence there in the bottom right, talking about as long as we provide the modeled equipment, we should be able to get those weights from the manufacturer because they're not often listed in the spec sheets either. So.
All right, so I'm going to jump in here and talk about equipment takeoffs. So the resources we're looking at, the methodology we've outlined leans heavily on the BIM model, pulling out 3D views and schedules and using that to quantify. Also want to look at the drawings and specs. The drawings give you a good high-level picture of what's going on. Also a good resource for identifying any anomalies that are happening in the modeling sphere. Also want to look at submittals if we're not at the submittal process for the project, potentially going to the manufacturer data like Joel just talked about, where we don't necessarily have the weight or that information on a cut sheet. All right, so similar to what we recommended for the ductwork and the piping and all that, I want to look at anomalies that are happening within the model, look at the level of development of the model, and then phasing. Keep an eye out for if there's any existing equipment that is shown. We want to exclude that, or future phases. Also look at variations in the modeling practices. There's sometimes where things aren't modeled. I think for the most part, equipment is modeled, but there could be cases listed here. Sometimes silencers are not explicitly modeled. There might be imported schedules, so potentially from CAD or Excel that's not actually live in Revit, or even some of the equipment shown on the drawings could be an imported schedule or an encoded link. Also look out for variations within the declared unit. How looking through those schedules, what can we use to quantify this? Weight isn't always listed, but that's the go-to. Another thing to look out for is type versus individual instances. I think this happens in mechanical equipment from time to time. Good example is fin tube radiators, where they might be listed as like an FTR-1, and it's just listed once in the schedule, and then there might be 30 or 50 instances of that in the model, and so we want to make sure we capture all of those. Another thing is operating versus equipment weight. Ideally, we're looking for the equipment weight, not the tank filled with water or all the coils filled up with fluid. Okay, so now getting into Revit, the first thing that we recommend doing is creating a 3D view that hones in on just the equipment. So you can see what you're dealing with, and then side by side, creating a custom schedule that looks at all of that equipment and tallies up the counts, so you get an idea of just how many you're looking at and kind of quickly see, and as well as the tags, what are all the names, and so then it can help you sort through the existing schedules that are in Revit. And this is that 1A, 1B instructions that Kaylee sent out earlier. All right, so I'm gonna try to pivot here and we'll see how this goes and do a live demo what I just talked about. So starting first with, yeah, we'll see how this works, with a 3D view. We want to peel that all back and just look at the mechanical and electrical equipment. So VV, get in here, recommend unlinking all your linked models. We also get rid of all of the imported categories, clean that up, and then we don't need to see any of the annotation categories, so we can get rid of that. And then now get into the model categories. That's where equipment lives. But I think first you want to uncheck everything. And then from there, do a search and just hone in on the equipment. So here we can see we have electrical equipment, food service equipment, mechanical equipment, and medical equipment. So, you might want to do one that's just electrical equipment and dig into that, or one that's just mechanical equipment. For this purpose, I'm just going to do both just to give you the visual. And there we go. So there's all of our mechanical equipment peeled away. You see there's something way out here. You can click on that. Oh, that's my generator. That makes sense that it's out on site, but still part of this project. But this is also a time to look if maybe there's some equipment way off that just never got deleted and isn't part of the project. So this is this first part of looking for those anomalies. Does this look right? Does this make sense? All right, so then we also want to create a new schedule. So I guess bring this over here. So right click on your schedules, new schedules, quantities. We're going to look for equipment and I'm gonna just do mechanical equipment. In this case, yeah, let's just leave it and say okay. All right, so what we want to do is find those tags, and it might depend on your model what everything is called. So that might take a little bit of digging. You can click on one instance and use the properties to sort of see how everything is named, how those families were created. You can see here I've got gen tag, equipment number, and equipment type. For this case, I don't want every instance. I'm just looking for the types. So I want to add that. I also want count, so I can search for that. And I don't think this is necessary, but I think this is helpful, is adding in the work set as well, so you can just see what work sets everything's on. And especially if you're digging in and just looking like just for the plumbing, you could see which plumbing work sets it's on and then create a schedule that is just, or a view and a schedule that's just plumbing related, for example. We'll do that. And let's see, I'm actually going to go back in here real quick because I want to. So we got those three. I'm not going to filter anything because we want all of the different types. And then don't need to itemize everything, but I do want to sort by the tag or the type. And then now we have something that looks like that. All right, so you can see active chilled beams, for example, we have 182. These are the terminal units, 100 of those. So just kind of a quick way of looking at what equipment you have, how they're tagged, and how many. And then we can look at this. Let's see if we can get this to work side by side. And what's handy about this is, if I click on one, I can highlight where they are in the model. It's just a great visual way of navigating that. All right, okay, so now from there, I'm going to go back to our PowerPoint. All right, and we are going to do some examples now of individual equipment types. All right, so for first one, this is a fairly easy one. This is, we looked at the DOAS unit or air handlers. In this particular project, we just had one, so and the weight was scheduled. So that's great. I go to the existing schedule in Revit, find the weight, and then go toward to finding an EPD that works for that. Oh, that is not. There we go. So if you needed to, let's say you had 10 air handlers and they're all similar type, you could go through and Kaylee's outlined it in the reference guide here, 3B, a weight-based custom schedule. So then you could just add up all that weight for those various air handlers. So for this one, we looked for an EPD that was applicable. And as you may know, there are many shapes and sizes for air handlers, so many different options. So ideally, we're finding something that is generally representative. We found one that is not expired. It's third-party verified. It does have very similar parts. It's got heat recovery wheel. It's hot water and chilled water coils. Does not have onboard DX, so it's seen representative. The things where it varies is it's not sourced from the same region, and I think that's a lot of the case right now because a lot of the equipment EPDs are coming from Europe, so this is a product environmental profile, and just Europe is way ahead on this, and so we're going to have to lean on that for now. And then you can also see that we're having to scale this quite a bit. This is a pretty small unit. The EPD is at the 6,000 CFM unit versus a 26,000 in our case. Same thing for the weight. So what we end up having to do then is take the weight of the equipment in the project and then scale by the EPD. So on a kilogram of CO2 equivalent per kilogram basis. All right, so that's the simple one. All right, then we looked at active chilled beams. This example is one where there's many instances of it. This is an example of the schedule, unreadable schedule. There's lots of them. It does list length. It also lists weight on this. So that's great. And we then searched for EPDs and we found an active chilled beam that has a 2x2 example that seemed like a good representative EPD. So then how do we scale that? All right, so I put this up here just so you can see like different processes because there's not like a one, they have to do it this way. It's like what makes the most sense for the equipment that you have and for the EPD that information that you have. And so, and then this is looking at 3 different methods with the one I'm recommending on the bottom and just sort of seeing kind of how it varies the outcome. So the easiest path here would be to add up all the length in Revit, create a custom schedule, which we detail in the guide, and get total length, and then take that EPD that we found in one click and just scale based off of linear foot. But when I looked into that, I saw that the EPD equipment has a different weight per linear foot than our project active chilled beams. So we're getting a discrepancy there. So we're, that's not as accurate and we're overestimating total impacts. Another way of doing it is doing a custom schedule in Revit. So that's this example here, adding up the weight and using that to then scale to that same EPD. The thing is when you look at this, when you actually look at the schedule, it says operating weight and not equipment weight. So I did a quick Google search, finding the manufacturer data for the base of design product and just say, what is the operating weight versus the dry weight? So so if I use that, see there's a slight difference there. So then went back and tried a third option, which is still totaling up that total linear feet of active chilled beam, but then scaling or then converting that to kilograms of active chilled beam based off of the actual product that they're planning on installing. And then from there, scaling the EPD. And so you see like this was pretty close, but it came down a little bit. Okay. All right, so then yeah, I'll go ahead and just keep going with this and then we can jump back over to Revit. So this is the fin tube radiators. I mentioned before that in this project, they were listed by type. So you can see FTR 1, 2, 3, and 4. But then the key here is when you look at the schedule, the length says see plans. It'll also sometimes say location various. And so that can key you into the fact that there's many instances of these. So um, what we ended up doing is creating a length-based custom schedule to figure out what the length is of each type. So you can see it here, FTR1, there's 142 feet of it, so on and so forth. And then from there, we looked at estimating the weight for each of those types. And you can see on the schedule that each one is slightly different. So we didn't want to just add up the total linear foot. I guess that you could kind of roughly estimate that, but ideally you're assigning a weight to FTR 1, 2, 3, and 4, and then scaling there. Okay, so with that, I'm going to jump over. We'll look at this here. Okay, so active chill beams, we are gonna look. So what I'm doing here is going into the properties and the fields, just edit it. This, I'm gonna not recreate it. I'm just gonna show you what I did. I basically created a new schedule like we did before, and then filtered for mechanical equipment. So created a mechanical equipment schedule. And then from there, filtered for that equipment type again. And then in this case, length. Now, one thing to note on this is if I were to do a filter for length, I get a lot of different things here. And so the first time I did this, I put them all over and figured out that it was dim underscore length that actually carried the length data. So sometimes it's a little bit of kind of playing with these to get it right. Now then what's different about this one is then we filter it, we filter by the tag equals to the equipment that you're looking for, custom schedule. So that then just gives us just the active chill beams. We then want to sort it. And in this case, sorting it by length, there are 4-foot and 6-foot chill beams in this project. This is handy here to get totals in the footer and then get grand totals at the very end. In this case, I'm itemizing every instance so that way I can see a whole list. And then one other thing that we're doing is in formatting. This is pretty useful, is if you want to calculate any totals. So you can see I'm not calculating totals of the type, it's of the length, calculate totals. So that was just originally no calculation. I switched it to here, and then that gives me this. So you can see if I scroll down, I've got the count of them and the total length for each of them. And then there's my grand total. All right, and let's see, pretty similar sort of thing. Oh, there we go. For the fin tube, was able to get the total length on each of these. Very similar sort of thing, except that added in the number there since that they're scheduled by type, as well as the length, filtering by FTR. I'm sorting it by number now so that I get a length per number. Yeah, so, all right. Okay, one more swap here, and then we're gonna get into electrical here. All right, so the last one I wanted to point out was terminal units. This one we recommend doing a capacity-based custom schedule. So that is one other instruction in 3C. And then basically sorting this by inlet size and then estimating weights of the terminal units based off of the inlet size, whether it's a 4-inch, 6-inch, or so forth. And so I guess I will jump over here as well. Just show you that real quick. So this is very similar as well. Create a new schedule, filter by mechanical equipment, definitely do that tag type. This is the field that you might have to sort through a little bit. One way to maybe, if you don't know what this is, to get the inlet size, just do some keywords. Inlet is what came up and got us the right parameter. But you can also then see if we jump back to if you were in your 3D view, you could go to one of them and then click on the properties and then kind of look through that and see if I have a good example of that. Let's see. How do I do this? All right, so for the example, there's your terminal unit, and you could look at your properties here and just see what are all the different parameters here. And I think it's at the very end. Yeah, here is what we ended up filtering by. So VAV duct size inlet unit, and that's either 4, 6, or whatnot. So that's what you end up grouping these by. All right, with that, I think we'll go back to the PowerPoint. Haley, you want to take it from here?
Yeah, that was great, Rachel, in terms of going through each different variation of mechanical equipment, how you might scale it. You could use any of those approaches really for any type of equipment, just depends what information is available. So say you may see slightly different things when you get into your model. The same thing applies when we get to electrical, although electrical equipment is a bit more standardized, right? You have set panel sizes. You tend to have 225 amp panels for lighting and appliance panel boards. You tend to have larger scale panels, something like an 800 amp panel. Transformers tend to be around 45 kVA. So we tried to provide ATSs we also have on here, the EPD that we referred to in the samples of the case study around how to scale each type of equipment so that you would have at least something to refer to. We also provided an uncertainty workbook with uncertainty against everything. So like Rachel was explaining, that air handling unit, almost perfect, except it wasn't regionally appropriate. And then it also, technology-wise, was a little off. So you could give it a slightly lower scaling on those. But uncertainty allows you to kind of make up for that difference. Joel's pump example, on the other hand, very far off in many ways. So maybe giving it a slightly worse score on the uncertainty there. So for electrical, when you go into OneClick, which is the tool that we're using for this, you will think that there are thousands of transformer EPDs, when in reality, when you start clicking through them, the ones that are applicable at building scale, far and few between. When I was going through them with an electrical colleague of mine, it was very difficult for us to find. He was like, Haley, that's the kind of transformer you put on a telephone pole. That's what you use kind of in like large scale applications, like 3000 kVA transformers. Trying to find something that was building scale appropriate was a bit more difficult. So that's why we've listed them out here. So when you're in Revit, you'll do basically the same thing that Rachel was just going through in terms of creating a schedule for the electrical equipment, looking at what you have overall in a 3D view, and then filtering down the amperage of the panels in particular. So I'll share an example of what that looked like in practice. So you can see the switch gear, you can see the individual panel boards shown in the 3D view of this project. Then when you go over to create that panel board schedule, it's the same thing where you just, Rachel had a slightly different method of doing this, but I usually just go to view and then create schedule. But under here, you'll see the parameters that are used around schedules. In this case, description was something that worked for me in terms of panel board versus other types of equipment. Family, that denoted the lighting and appliance panel board facet. And then the main size, the main breaker size, that allowed me to say, okay, who should be grouped against that 225 amp panel, and then who should be grouped against the 800 amp panel, since those were our two frames of reference. So being able to use the main to sort here, sorting by or filtering by the description equals panel board, and then being able to get the total values associated with the mains was really important here, as well as you'll see that kind of title, count, and total at the bottom here, and itemizing every instance. So for the 225 amp panel, getting the totals against each individual size. We've got 60 amp panels, 100 amp panels, 150, 200, 225, 250, and then 400. All of those get added together. So doing an additional filter to say, okay, those 2500 amp panels should not be equivalent to a lighting and appliance panel board. There's probably closer to that 800 amp panel, separating those out from each other, doing the grand total of amps, and then dividing by 225. When looking at the sizes of panels as they scaled up, that felt appropriate as part of this study in terms of saying, like, does the size match up per what we spec'd on this project, weight-wise? So scaling by amps, just divide that number in total by 225 to get the quantity associated with the panels on here. The same thing was done for, or maybe I don't have the one separated out, but for transformers. So you could separate out transformers and divide it by 45 kVA or 50 kVA, whatever we had specified there, so that you're getting that kind of scalability, but doing it by capacity, or amps in this case, which was pretty useful in the space of electrical. But the EPD quality was sufficient for the purpose of this project. Rachel, if you could share the slides again. You're muted, Rachel, but I see you thinking. Did you want me to share the slides, Rachel? We can't hear you. I can see you mouthing, but yes. Okay, I will share the slides. So we've got the takeoffs and EPD section here. This is really helpful just in terms of that general understanding of how to scale. Again, Rachel had those examples of the two different methodologies against chilled beams. The same idea applies here. So something like a generator, weight is more appropriate for scaling, and it's typically available. So just taking the overall weight of something like your generator on your project and then dividing it by the reference EPD size. We found that to be especially appropriate on air handling units because something like a 10,000 CFM unit can be 4 times as much weight if you've got a custom unit versus something that's kind of out of the box, assuming that the material quantities scale in a linear fashion. That's why weight is generally a more appropriate scale factor there. I think that was it on the electrical equipment side. I'm not sure, Rachel, if I was going over results as well. Okay. Sorry, I think we're having a little audio issue here. So on results, same process. This is actually showing the piping results right now, but I can flip over to what this looked like in here. So getting the number of units in total for, lighting and appliance panel boards, that kind of heavier 800 amp panel, I believe it was, and then the automatic transfer switches, how many we had there, and then the number of equivalent 50 kVA transformers. And then you are able to look at the results here. You recall you would hit details under A1 to A3, And then we can show numbers against these just so you can see, 13,000 kg CO2 for the 14 units. And this is the information that you will transcribe into the data entry sheet. So just entering the appropriate quantities in here against those categories. Now, if you have additional electrical equipment categories, we did provide an other under here. We don't want the results to necessarily be all over the map. And we know for mechanical equipment, you will certainly have other pieces of equipment that are not in this list. We tried to make it as comprehensive as we could, but I think being cognizant of the fact that you may have additional categories here, please let us know what categories we're missing so that we can expand that drop down to be as comprehensive as necessary. So that's a goal that we have here, is that we try to capture all of the higher level categories that we can, but there are sure to be things missing because we were looking through the lens of only a couple of projects when doing that. So yeah, please give feedback to us on additional categories that are required as you go through the data entry template. I guess we've got time for questions if people have them up front.
I've got a couple. Are we tracking data uncertainty for this?
So that's not in the data entry template at present, I don't think. Hold on, let me just double check. Yeah, we did not add uncertainty in this template. However, as part of the overall guide process, there is a full uncertainty procedure you go through. The way uncertainty works per RICS is that you would choose your top 10 most impactful categories, and then you perform uncertainty analysis against those and get the sum. You also do it at the project level of what LOD you are, how far progressed the drawings are. So there are a couple of different facets of how uncertainty is calculated as a whole. But for the specific product LCAs that you were able to pull, you choose the most impactful products. So when we get to that section, I think we have a couple of weeks dedicated to uncertainty. We can go through and calculate that, but at present, it's not part of the data entry template. And how and when we choose to include that, 8% uncertainty factor on here kind of remains to be seen, and how we report the results, maybe with and without uncertainty added on, would be helpful.
Okay. And then I guess sort of related, are we supposed to be solely relying on EPDs for finding online, or would it be like if we want to go get like a TM65 done by reach out to a manufacturer and we get that information, is it okay if we use that for the embodied carbon data?
Yeah, use whatever it is that you have at your disposal. But again, think about the principles of uncertainty as you're specifying EPDs, because TM65 is off in some realms, right? It's not third party verified. It's just thinking about the facets that Joel went through in terms of what's the best data that I can find. I'd say probably in the case of that 2 kilogram pump, having a TM65 method might be preferable because technologically it'll be a lot closer. It's the manufacturer you specified, it'll be regionally appropriate. You're kind of eliminating other areas of uncertainty by doing that.
Yeah, for sure. Pumps was one I was thinking. We were able to get some large pump TM65s. Problem is when we got them from the supplier ended up doing the TM65 themselves instead of filling in the form so I could do it, and they made a mistake. And so I've caught their mistake and corrected it, but it's not good data because I had to correct a mistake that they made. So
yeah, I think we'll get better at that process. I've seen a lot of really good TM65s come out of the UK where they've been practicing for a bit longer in terms of gathering that data, and manufacturers like Mitsubishi even providing a nice cute little form that it comes out in where it looks closer to an EPD, but it gives it a little bit more, I think, fidelity just in terms of it's polished, and people have QA'd it. So
okay, sounds good. Thanks.
On the TM65 front, I haven't seen a way to kind of use basic level TM65 data within one click. It seems like advanced, if we can get the intermediate level, that marries pretty well with one click inputs. Has anybody found a way to do a TM65 basic with one click?
not sure if Eliana is still on the call. I thought I saw her earlier.
Perhaps,
Mirko?
perhaps I can take it. So on one click, you can create your own, let's say, assembly. So in this case, what you could do is you can enter the TM65 data, and you can create your private, let's say, TM65 reference. You should have the what's called, not the business, the advanced license, to be honest.
Okay. Digging into the TM65 methodology, because that's what I was thinking would be the way to do it. But digging into the methodology, that basic level to deal with the uncertainty really hinges on those scaling factors and complexity factors. And I haven't found any, and that covers, I don't remember what the lifecycle modules are, but it covers multiple one scaling factor covers A4, A5, and C, and whatever they are. And I haven't found a way within one click to do that. Whereas if you get the intermediate data, it actually has that broken out. So I just didn't know if anybody had run across that. Sounds like maybe not. Too new.
Yeah, I think OneClick was making a pass. They may have already integrated some of the SIBS ETM65 data from the UK in terms of getting that over and integrated, because people have been gathering it for a while. So I don't know. I mean, the American version just came out, so I assume it'll be a bit.
No, I have seen the TM65 data in the OneClick database, but like I said, I just don't see a way to apply the TM65 methodology with basic data within OneClick. So, okay, thanks. Appreciate it. I was hoping someone knew something I didn't.
No, thanks for raising the question. We could always, Spencer Jarrett, who you may have already had contact with, you could always reach out to him to see what the development team's plan is for that, or what the best path is, and he probably would have some good advice.
Okay, thanks.
Is the issue because we're only trying to get A1 to A3 for this, and so because TM65 basic level uses one scaling factor and doesn't split it out, you can't then just get that A1 to A3?
Actually, no, that's a good point. So we're doing a parallel study that is not just A1 to A3 for the same project, and because we were already contracted to do that under TM65 methodology, and I'm just getting my two sides of the same project crossed. So it would work for this, I guess, for A1 to A3. It's just for the life cycle where it is not fully applicable from what I found.
Yeah, I know for us, when we're using TM65s for kind of broader stuff, we just haven't been using OneClick for the MEP since it didn't really work well prior to this. So like we spreadsheet it and then we're able to kind of pull it in. So maybe that, like, I guess as a fallback, maybe you have to add it in after the fact by hand.
Yeah, that's where we're at right now. So cool.
Yeah, I think
Thank you.
that was our general approach to use of OneClick at this stage, is because none of the factors past A3 were the same. They don't have the data sets embedded yet because they're from lots of different sources. It doesn't stick to one set of rules. Everything beyond that is in the spreadsheet right now rather than being in OneClick. But I think in terms of having that pool of EPDs and TM65 methods and general OneClick data, it's a good repository of EPDs. So I think if you have to substitute in some other data in the rows, should be okay for the purpose of this study.
Absolutely. Okay, thanks. Appreciate the input.
Any other questions or thoughts? All right, so once everyone digs into this over the next week, hopefully you'll come back with lots of questions on how to scale different pieces of equipment, or, different conundrums you might have, which you're bound to, because we've encountered so many different kind of, you could do it this way or that way, or what's the kind of method we want to coalesce around. And when we initially did the case study, we broke it up alphabetically, so people had different chunks of the alphabet of equipment. because there's enough equipment for that to happen. So I think just digging into it and seeing what you come up with so that you're able to kind of soundboard within this group. So if everyone could try to do that by next week, that would be great. Otherwise, thanks for the great session. Thanks to our presenters today.
Thank you.
Thanks all. Have a good one.
Thank you.
Thanks.